so we can stay on time here. Thank you for having me. I wanted to start out by thanking our partners at XENON for inviting me and for helping us install a great system together out at POSI last year. So I'm Bruce Gilpin. I came over from all the way from Portland, Oregon. This is my first post-COVID conference, so just really getting back into the swing of things, but it's great to see people talking, and I've seen a bunch of colleagues that I hadn't seen for 2 or 3 years, so it's great to be here, and thanks for listening to my presentation. We're a company that's focused on managing data collections, mass storage systems. Large archive is our market segment. So kind of the opposite of vast, even though they say they do archiving, they really don't. So that still leaves a big market segment for us. And what I've put up here is just to speak to a few of the trends. The title of the topic of my presentation was the future of mass storage. And so I just wanted to throw out some kind of trends that we're seeing with the biggest sites that we work with, which are some of the U.S. national labs and some defense sites. And there are some interesting trends after a period of relative stability and almost bordering on stagnation, I would say, in these architectures. And they're really starting to shift now. People like VAST are part of that shift. But what I've got is just a very simple diagram here where at the top is the compute cluster, and that's really not thought of as storage, but one of the changes we're seeing is the compute clusters have more and more memory, and now petabytes of memory. And what having all that memory up in the machine is doing is putting pressure on what's below it. And so the scratch file systems are, in some of these cases, getting smaller. They were getting bigger and bigger for years, and now it's going the other way. They're getting smaller, and some people have a vision of the future, some people with very big budgets, where there is no scratch file system. There's no parallel file system. Everything's either in memory or it's going down into the orange box where we play. And so this is where our company and our software works, which is campaign storage, or a data lake if you're calling it that, which is an object storage tier, so warm storage. And then all the way down to the archival tier, which is still mostly tape. So those getting larger, scratch getting smaller is sort of one of the big trends that we're seeing. A little more about us. We have a global installed base now. We have not raised hundreds of millions of dollars like some other of the emerging companies. We actually built our entire company from customer revenue and a little tiny investment at the beginning from HPE. But we've been able to grow a global user base. We're creeping up towards 2 exabytes of data under management. So a lot from a pretty small company, private company. And our story is up there on the slide now. We started in 2011. I did a whole keynote right before COVID started on how difficult it is to do a data startup in the HPC world. It's very closed. It's very difficult to get customers to experiment or take risks, especially with their long-term storage. So we really had a tough job in front of us to come out into this industry as a new player. But we did that, as you can see on the chart. That's actually our quarterly revenue since we started the company. So it started at 0, and we don't disclose what it is now, but what you can see from the chart is that it's gone up really fast. And that's really basically an indication of demand. People need this type of software. They're deploying it more and more. People who had medium-sized data collections yesterday have huge ones today. And the huge ones are becoming just spectacularly large. So a lot of work, a lot of demand for the product. Whenever I put a slide up there showing this nice smooth growth, I always want to acknowledge, in case there's anyone in the audience thinking of starting a company or who has a startup, that getting there was just a complete convoluted journey. It always is, right? I love this graphic in the middle, and if you can't see it, it says, you started here, and then success is over here at the top right, but in the middle, a whole lot of kind of crazy stuff happens. So I can't say that it was easy, but we have kind of reached escape velocity now, and made a huge transition in the technology. So we started with a product called Versity Storage Manager, and then in the last few years, we've introduced a whole new platform called Scale Out Archive Manager. And Posi, who I think is here, Chris, was the first big global site to adopt that technology. So it's really fun to be out here at eResearch, in the country that was willing to kind of go first. So we built a big system for Posi. I'll talk a little bit more about it later. This is just a quick diagram of the platform. We sit in between primary storage systems, and we are running and orchestrating all of the reads and writes across the archival tier, which again is mostly tape. So I don't have time to really go into the nitty-gritty, but we support both file and object on the front end. And the Posi system we built is entirely speaking to the archive, doing all its reading and writing into the long-term storage using S3. So we have a really scalable S3 front end, and then we support all different protocols on the back end to reach the back end storage systems. This slide is also about kind of trends and evolution. In our market segment, managing these big long-term archival systems, there's kind of three big barriers and roadblocks to progress that hit our industry at the same time as these exascale systems were being built. And so I've broken them down into what we view as the three big ones that were the toughest challenges. And I've kind of got some comparisons here that I'll go through quickly. The first one on the left is namespace scalability. People were putting such large numbers of files into namespaces that the ability of these archive management tools to manage those namespaces began to falter. We have a competitor who has an actual hard cap on the number of objects they can manage. And once you hit that cap, it will not archive one single additional file. Most of the products don't have caps. They just get harder and harder to manage and slower as the namespace grows. Because there are lots of day-to-day chores, hour-to-hour chores that a large archive system has to do that requires scanning through the file system. So that scalability was a big problem, and it went from, needing to manage hundreds of millions of files in a namespace to needing to manage tens of billions. And we've made that transition, but it's a tough one. Scanning, even in an improved file system or a modern fast file system, is still problematic because you've got to do tons of I/O to touch all those files and check their status. Our design spec going in was we will never, ever scan the file system. A user could invoke a scan, but we, in the process of managing our data, will not have any functions within the platform that scan the file system. And so the way we architected our system is that everything that used to require a scan is just serviced with a query. And we were able to do that without tacking on a database. So the query is occurring within our data structure that we manage and that we built within the file system. So this is a shared block file system that has some specialized data structures that allow us to index certain attributes within the file system. So when we ask for hey, how many unarchived files do I have out of my collection of 10 billion files, it might only be 20 or 30 or 50,000 files. We can query that and get a sub-second response, whereas the old architectures used to walk through the whole collection, which could take hours, if not days. And then the other thing was just protecting these collections. So you have to dump your file system to protect it, to protect the metadata. That's no longer feasible at even 5 billion files. The dumps could take a week, which is a very large window of exposure. So we came up with incremental dump technology, which has been around for years in other products, but never in this domain. So we're introducing that feature this quarter. And so we're just dumping the differential, the deletes and the additions that came in since the last dump. So that's very powerful. You can dump your system in a few minutes instead of hours and hours. And then last but not least, there's been typically these big archival systems are just operating at one location at a time. You can ship your metadata to a remote location for DR, but it's not available. It's not an exposed namespace. And so we have built also a feature called replication, where we're able to federate out that namespace. The DR location is fully operational. It's a fully functional, viewable namespace that's running with a time delay from the primary space. So the replication is really super valuable. You can actually use your DR site, and if you ever have to switch to it, there's not a big, long restore procedure. Data parallelism is the other one. So this is forget metadata. We're just talking about how many data streams can we launch and maintain simultaneously out to the back ends. With LTO9, we're getting close to a gigabyte a second per drive if the drive's running at full speed. So if you have 50 drives and you want to run them all at full speed to move a checkpoint quickly into the archive, for example, one of our customers does 1 petabyte checkpoints. Well, they need those archived really fast so they can make room for other stuff. And so we want to engage as much back-end hardware as we can, which means the tool has to be able to put an incredible amount of data in flight in parallel. It used to be that, going back even maybe 4 years, there really was only one product in the whole world that could do this kind of full parallel writes out to tape. It was IBM's HPSS product. And so that's a very complex product. It's got lots of pluses and minuses, but it was the only one. And so we really wanted to bring some democratization out there, give people a choice. And so our product now also writes in that full parallel modality. And then the last one is probably the nearest and dearest to my heart and where we've differentiated the most. If you get past the feature by feature analysis, then you get into this column of just, okay, well, what's the overall value? And I don't mean what does it cost, per gig. I'm talking holistically. How many people do you have to employ to run it? How long do they have to be trained? What happens if they retire? And so these attributes are becoming more and more important, especially as the cloud vendors remove operability from the equation. So even people who aren't going to go to the cloud need cloud-like products that are easier to run and manage. So the first thing we tackled was, hey, it needs to be an RPM install that you could do even on a large system in a half an hour. Now, I'm not talking about infrastructure planning and all the other stuff that goes into building out a large site, but the actual installation of the software. Could that be done in 5 or 10 minutes? And we've gotten there. We have rolling upgrades and we have really easy, fast installs. It does crazy advanced stuff like crawl out and detect all your drives. You don't have to do any mapping. So the time involved has just gone down to almost nothing. And then, how difficult is it to run and manage? We've made it really easy. We shot for, incredible scalability and incredible performance on the platform. But there's always two ways to get there. You can go complex or you can go simple. And so we really focused equally on simplicity and manageability when we built this product because we knew that we couldn't just come out with a science project that took 15 people to run. Customers don't want that anymore, and they don't have the money or the people. So that's been very successful. We built a GUI. Initially, all of our installed base said, oh, don't bother, we don't use it. Once they saw it, they start using it. It allows a junior admin to check on the system, see what's in flight, see the state of the cache. The entire tape catalog is viewable, sortable on the screen. It is dramatically better than a command line. We still have a CLI that's fully supported, but the GUI on our product is a REST API-driven complete interface for the product. Even the initial policies you set up can be done in a little wizard on the GUI. So that's really helped us. And it may seem obvious if anyone in the audience just uses normal storage products. Of course, they all have GUIs, but our class of product and our competitors typically do not. And if they do, it's a very primitive GUI. So big investment there that's paying off. And then I guess the other thing I want to touch on is just the architectures. We went with a unified architecture. You get everything from Versity. Our engineers wrote every single element of the file system and the archive application. So it's very tight, very small, compact, manageable package. The other players that are in our class went with third-party technologies, third-party databases that give them the scalability they need. Okay, and that's a viable approach, but it means the customer has to pull in and manage and operate that third-party tool. So it's very different philosophy, different approach, and it's working really well for us. I think the last thing is traditionally these systems have been really monolithic, meaning that they're very hard to change or expand. Ours is totally modular. If you need more throughput, you add more servers. If you need more, some pictures of our GUI. If you need more block storage, you add block storage. And of course, the back-end archival storage can be expanded. And then I'm going to wrap things up and just do a very quick Q&A, but I wanted to highlight one other important thing here, which is it's one thing to build a better mousetrap, a better technology, but if no one can switch to it, you're kind of stuck. You're not going to gain market share or help a lot of sites. We put a ton of energy into our conversion capability, and so what we're able to do is natively read the data formats of our competitors' platforms. They hate me for this. I have to look under my car and make sure no one's planted a bomb when I get up in the morning. But they would like this to just disappear. But it's here. It allows people to switch to our platform without first reading back all of their data. We can talk in more detail about that if anyone's interested. This is just a quick overview of the big system we built with XENON for POSI, 150 petabyte system. We converted this site from DMF. So they dumped their DMF metadata, restored it into our product, and immediately we're able to go into production. If someone reads an old file, we just traverse across the DMF tape set, we read it, and serve it through our platform. And any questions?
Thank you very much. I'll come up on the stage. All right, so we've got time for a couple of questions, so I'm going to try and see you all out there in the audience. Does anyone have a question? All right, while you're all thinking again, I've got my one saved up. I think it's really, yeah, I'm going to have one. It's my chair prerogative. It's really interesting that data's got a spectrum, right, and the storage solutions that you're delivering across these two speakers has that spectrum. You're on that archive spectrum. So what are you thinking about in terms of digital preservation? Are you playing in that space as well? Is that somewhere you're thinking about?
Yeah, we're, in addition to, like HPC archive, we play in a whole bunch of other verticals, media and entertainment, other big data consumers like geospatial, defense, anywhere where there's big collections of assets. And digital preservation is a huge use case. We're not the higher level stack where we help organize it and help curate it. But those systems will write data into our system, which in turn, secures those copies long term. So, yeah, digital preservation is big. We manage the Australian National Library on our platform. along with the Library of Congress. So yeah, when it has to be there forever, this is really the class of product that's used.
Fantastic. All right, so looks like we've got everyone filtering in. So please thank Bruce again for a great presentation.